Hello, grade 8. This is Mrs. Lopez. We are in our module 1, last lesson of this module about scientific notation. Lesson 10 brings everything together, and we are practicing all the operations we learned using numbers in scientific notation. We've learned addition, subtraction, multiplication, and division. And these are the bunch of problems that just summarize what we've learned, giving you a bunch of practice. So let's start with exercise 1. The speed of light is 300 million meters per second. The sun is approximately 1.5 times 10 to the 11th meters from the Earth. How many seconds does it take for the sunlight to reach the Earth? Let's think about that very quick. So this is our speed. And this is how far the sun is from the Earth. So this is the distance. So we have the speed, we have the distance. How do I find the time? How many seconds? That is time that I'm looking for. Does it take for sunlight to reach the Earth? I know that it takes time to get to the distance, and we are traveling with a certain speed. So if I divide distance by the speed, I should be able to get to the time. So that's what we are going to do. We are dividing distance by the speed, and we will be able to find our answer. Our distance is 1 and 5/10 times 10 to the 11th, and we are dividing it by 3, and we are going to convert our 300 million into scientific notation, which is 3 times 10, and we have 1, 2, and 6 more, so 8. 3 times 10 to the 8th power. Okay, since we are dividing, we can divide 1.5 and 3 and subtract the powers of 10 because they have the same base. So 1.5 divided by 3 is 5/10, and we are multiplying it by the 10 to the 11 minus 8th power, and that is 5/10 times 10 to the 3rd. Okay, now I see that 5/10 is not written in scientific notation because our whole number has to be equal or more than 1 and less than 10. So I'm going to rewrite that 0.5 into 5 times 10, and to get back to 0.5 it has to be a negative 1 because I'm going to move backwards. So negative first power, and that is times 10 to the 3rd. Okay, so now this is a multiplication problem, and I have two numbers with the same base, different exponents. So I'm going to combine my exponents. 5 times 10 to the power of negative 1 plus 3, and that is 5 times 10 to the 2nd power. And I can write that in a standard form, which is 5 multiplied by 100, which is 500. Okay, so it takes 500 seconds for the sun to reach the Earth, for the sunlight to reach the Earth. You would think it's a lot, but the fact that how fast it travels actually is pretty fast. Let's look at exercise 2. Okay, so the mass of the moon is about 7 and 3/10 times 10 to the 22nd kilograms. It would take approximately 26 million moons to equal the mass of the sun. Determine the mass of the sun. And notice how we are working with real life problems, and this is so much fun, I think, because you are learning not only the math problems, but you are working with real life things. And these are the planets, so we are talking about science. So, and astrology, I really, really like that. Astronomy, we really like it. I do really like it. So, we are looking for the mass of the sun. I know that that is one moon, and I know that's how many moons it will take. So I will have to multiply to get 1 moon by that how many it takes to get to the mass of the sun. So I will take 7 and 3/10 times 10 to the 22nd, and I'm going to multiply it by 2.6 times 10 to the 7th, because that's where my decimal is going to be. I will have 7 digits after the decimal. So 2.6 times 10 to the 7th. Now this is a multiplication problem, so I can rearrange my numbers any way I want. I can do 7 and 3/10 times 2 and 6/10 times 10 to the 22nd times 10 to the 7th. Since it's all multiplication, I'm multiplying my decimals, and that is 18 and 98 hundredths, and I'm multiplying it by 10, and I'm adding the exponents here, 22 plus 7. So I will have 18 and 98 hundredths times 10 to the 29th. Now I'm looking at my 18 and 98 hundredths. Is it written in scientific notation? The whole number is more than 10, so no, it is not. We need to move our decimal backwards one. I'm going to decompose that number into 1 and 898 times 10. What do I need to do to bring it back? I need to multiply by 10 to the first power. So to the 1 and 898 thousandths times 10 to the first, and that is times 10 to the 29th. I have a multiplication problem where I have two numbers with the same base, different exponents. I'm adding the exponents together, and I will get 1 and 898 thousandths times 10 to the 30th power. Okay, moving on to the next one. We have 5 problems here, all. Exercise 3. The mass of the Earth is 5 and 9/10 times 10 to the 24th kilograms. The mass of Pluto is that many kilograms. Compared to Pluto, how much greater is Earth's mass than Pluto's mass? So let's look at the key word here. How much greater? They're not asking us for how many times. They're asking us just to compare one toward another. How much greater? Since we are just comparing, we are subtracting. We are finding the difference between the two. So first, I want to rewrite this long number into scientific notation because I don't even know how to pronounce it. I have 1.3 times 10, and now I need to count how many digits I will have after the decimal. So I have 3, 6, 9, 12, 15, 18, 21, 22. So 10 to the 22nd power. Okay. So now I'm going to subtract one from the other. I have 5 and 9/10 times 10 to the 24th minus 1 and 3/10 times 10 to the 22nd. Can I subtract them right away? No, because that is my first term and that is my second term. I cannot just subtract 5 and 9/10 and 1 and 3/10 because they are multiplied by 10 with different powers. I need to make sure that my powers are the same, my magnitude is the same. So I'm going to decompose 10 to the 24th into 10 to the 22nd times 10 to the second. This way, if I add them together, I will get 24th, right? So I have 5 and 9/10 times 10 to the 22nd times 10 to the second minus 1 and 3/10 times 10 to the 22nd. Okay, so I have power of 22nd, I have power of the 22nd. I also have power of 2, which is not needed here. So what I'm going to do, I'm going to multiply 5 and 9/10 by 100, and I will combine these two together. This way I will eliminate the 10 to the power of 2. So I have 5, 9. This decimal was here. I'm multiplying by 100, moving my decimal twice. 1, 2. I have 590 now. 590 times 10 to the 22nd minus 1 and 3 tenths times 10 to the 22nd. Now I have powers of 10 to the 22nd power, and I can use distributive property to take that 10 to the 22nd outside the parenthesis. So I will have 590 minus 1 and 3 tenths, and that will take in parentheses to be able to subtract, and then I would multiply that by 10 to the 22nd power. When I subtract 590, and 1 and 3 tenths, I will get 588 and 7 tenths times 10 to the 22nd. Notice that 588 and 7 tenths is not written in scientific notation. So I'm going to decompose that number and make that 5 and 887 times 10 to, and to make it backwards, I need to multiply by 10 to the second power, and times 10 to the 22nd. So now I can combine my exponents, and I will get 5 and 887 thousandths times 10 to the 24th power. That will be my answer. That's how much greater the Earth is than the Pluto. Let's look at exercise 4. Using the information in exercise 2 and 3, find the combined mass of Moon, Earth, and Pluto. So let's look at the size of the mass of the Moon. Mass of the Moon was 7 and 3 tenths times 10 to the 22nd. 7 and 3 tenths times 10 to the 22nd. The mass of the Earth is 5 and 9 tenths times 10 to the 24th. And the mass of Pluto from here is 1 and 3 tenths times 10 to the 22nd. Okay, so since we are looking for combined mass, that's why we are adding the 3 together. That's why we are using addition. Notice I cannot add them together just yet, because this power is the 24th. It's different from 22nd that I have in the other two. So I will have to decompose that 10 to the 24th into 10 to the 22nd times 10 to the second again. And so I will have 7 and 3 tenths times 10 to the 22nd plus 5 and 9 tenths times 10 to the 22nd times 10 to the second plus 1.3 times 10 to the 22nd. Okay, so now again I have 10 to the 22nd, 10 to the 22nd, 10 to the 22nd, and 10 to the second that I don't need. So I'm going to use that term and multiply it by 5 and 9 tenths. I will have 7 and 3 tenths times 10 to the 22nd plus, and just like I did in the previous exercise, I'm multiplying 5 and 9 tenths by 10 to the second, moving my decimal twice to the right, and I will have 590 times 10 to the 22nd plus 1 and 3 tenths times 10 to the 22nd. So now I have 10 to the 22nd multiplied by all three numbers here. So I can take it outside the parentheses using distributive property. So I will get 7 and 3 tenths plus 590 plus 1 and 3 tenths, it's all in parentheses, and I'm multiplying it by 10 to the 22nd. Now I can combine the three numbers, and I will get 598 and 6 tenths times 10 to the 22nd. 598 and 6 tenths is not written in scientific notation. I need to make sure that my whole number is more than a 1 and less than a 10. So that means I have to put my decimal after the 5. So 5 and 986 thousandths times 10 to the, and to go back I will need to multiply by 10 to the second. and times 10 to the 22nd. Now I can combine these two powers and I will get 5 and 986 thousandths times 10 to the 24th. Now we're all done. That is the combined mass of Moon, Earth, and Pluto. Last problem here. How many combined Moon, Earth, and Pluto masses are needed to equal the mass of the Sun from the exercise 2? So we are using combined mass, which is this one, and we are using the mass of the Sun, which is our answer in exercise 2, which is 1 and 898 thousandths times 10 to the 30th. And we are going to compare them. How do we compare them? They're asking how many can fit into the mass of the Sun. That means we will have to divide, because if I ask how many times can 3 go into 6, you will tell me 2 because you are dividing 6 by 3. So we are going to divide the Sun by the combined mass here. So I will get 1 and 898 thousandths times 10 to the 30th, and I'm going to divide that by 5 and 986 thousandths times 10 to the 24th. Now I can use my calculator to divide these two numbers. You will get a number that does not end. However, I'm going to use first 5 digits after the decimal there. I'm going to write 0 and 31707 times 10 to the 6th, because I will have to subtract these two, right? 30 minus 24. Actually, I'm going to write that here. So it's 0.31707 times 10 to the 6th. Now, I will be able to move my decimal 6 times to see the combined, the actual number of Moon, Earth, and Pluto masses. So I will get 1707, and I'm moving my decimal 6 times. 1, 2, 3, 4, 5, 6. I can erase that 0. I have 317,070 times we can fit Moon, Earth, and Pluto masses into the mass of the Sun, which is, I think, pretty cool. Okay, so you have 3 problems for homework as a problem set. Try those out, and I will see you in class.